This is a review of Standard 8 EEA1. We are going to see how to handle expressions and equations. In fact, in this, we're going to know and apply properties of integer exponents to generate equivalent numerical expressions. We're going to be dealing with exponents. Now, the first question, what are exponential expressions? Let's look at this. If we've got something written like this, a to the x power, where a is a variable, x is our exponent, a is the base, x is the exponent. And the x tells us how many times we multiply the base by itself to get the value of the equation, or the expression. In this case, 5 to the third power would mean 5 multiplied by itself 3 times. 5 times 5 times 5, which would give us 125. Now let's review how we use this. What if we're multiplying exponential expressions with like bases? Like bases means that the bases are the same. In this case, our base is both the variable b. Here we're raising b to the m power, and we're multiplying it by b to the n power. So b to the m power times b to the n power is equal to b to the m plus n. Notice how we're adding our exponents? When we multiply with like bases, we add the exponents. Here's an example. If I have 5 raised to the third power times 5 to the sixth power, I have the same base. In both cases, they're 5. What I do is I add the exponents. That gives me 5 to the 3 plus 6 power, or 5 raised to the 9th power. That would be 5 times itself 9 times. What if you're going to divide exponential expressions with like bases? Say you've got a to the x power, and you divide it by a to the y power. In both cases, a is our base. This is the same thing. A is the same base. So what we do is we subtract our exponents. That would give us a raised to the x minus y power. When you have the same base and you're dividing, you simply subtract the exponents. An example would be 7 to the 5th power divided by 7 to the 2nd power. That would give you 7 to the 5 minus 2. See, 5 minus 2 power. 5 minus 2 is 3, so this is 7 to the 3rd power. 7 to the 3rd power is 7 times 7 times 7. Now let's continue our work with exponents. See what happens if we raise a power to a power. What if I've got the base d raised to the r power, and I raise this whole thing, d to the r power, to the k power? When I'm raising a power to a power, I multiply the exponents. That would give me d to the r times k power, d to the rk power. An example would be like this. 3 to the 5th power, and all of this raised to the 2nd power. If I've got that, that gives me 3 to the 5 times 2 power, or 3 to the 10th power. Notice we don't do anything with this here. We simply deal with multiplying the exponents. What if I raise a base to the power of 0? Anything raised to the power of 0 is equal to 1. P to the 0 power is 1. The value of any expression raised to the power of 0 is equal to 1. I want to show you some examples and talk you through why this is true. 3 to the 0 power is equal to 1. X to the 0 power is equal to 1. Anything to the 0 power is equal to 1. Think about 2. What if I raise 2 to the 4th power? Isn't that 2 times 2 times 2 times 2? Which is 16. 2 to the 3rd power would be 1 less 2. 2 times 2 times 2, which is 8. You could get that by taking 16 and dividing it by 2. 16 divided by 2 gives you 8. 2 to the 2nd power is 2 times 2. Well, if 2 to the 3rd power was 8, I could simply divide 8 by 2, and I would get 4. 2 to the 2nd power is 4. 2 to the 1st power is just 2. If 2 to the second power was 4, couldn't I simply divide that by 2? Wouldn't I get 2? Now, how about 2 to the 0 power? If 2 to the first power is 2, wouldn't I divide this by 2? 2 divided by 2 to find out what 2 to the 0 power is. 2 to the 0 power is 2 divided by 2, which is 1. Anything raised to the 0 power is equal to 1. What if you raise a base to a negative power? In this example, I have g raised to the negative x power. That's going to be equal to 1 over g to the x power. It creates a fraction, 1 over this to the positive power. If you've got this example, 3 to the negative 2 power, that's equal to 1 over 3 to the second power. See how the power changes from a negative value to a positive value here? 1 over 3 to the second power. That would be equal to 1 over 3 squared. 3 squared is 9. 3 to the negative 2 power is equal to 1 over 9. That's a review of standard 8EE A1.